Finally, it is good to look at the quests of trying to find life beyond our planet or aliens in a quantitative way. And perhaps the most famous way to try to do this is through Drake's equation. This tries to essentially quantify how many civilizations might be out there in the galaxy that we could establish contact with. In order to try to calculate it yourself, all you have to do is to have decent estimates of, for example, the total number of stars on the main sequence, then determine the fraction of stars with planets. And the great news is that we now know these numbers really, really well. We know that there's at least one planet per star, and we also know how many stars there are in the Milky Way. But you also need to know what is the number of planets per star that may harbor life. This is way harder to know. We can have a guess, but it's really hard. And then all the other terms become really, really uncertain, such as the fraction that actually develops life. This tells you about the potential, but this is about whether it actually happens. Then we need to consider the fraction with intelligent life, the fraction that actually develops technology, and finally, how long that civilization will last for. And a lot of people have actually used this in different contexts, and the answer is that it could be anywhere from below 1, which would be worrying because we are here, so you expect the number to be at least 1, but all the way from below 1 to something like 1,000,000 or at least hundreds of thousands. And the reason for this huge range of essentially 0 to almost infinity has to do with our ignorance of all these parameters. But at least just for fun, you can also plug in some of the values, and I left some of my own estimates, and feel free to actually plug them in into the calculator to see how many observable alien civilizations we would be able to contact. Another thing to be aware is the capability of said aliens or civilizations to actually be looking at us and detect us. We've only been around for a relatively short amount of time, and our communications can actually only be traced back to about 1936. Unfortunately for humankind, I guess this is our hey there. This was in the Olympic Games in 1936, and it was one of the first major broadcasts that could actually make it to space, and that is now traveling through interstellar space. But this also means that given a specific distance to the Earth and the planetary system that you might be looking at, they can only see essentially a given amount back in time. This means that stars are sufficiently far away, they might be able to start seeing emissions and TV broadcast, but those that are further away, they could look into Earth and they will see nothing. And they may think that there's absolutely no live broadcasting signals, even though that is not true. It also means that depending on your distance, if you're plugged into channel Earth, you might be able to see different seasons of your favorite show as they essentially arrive there. Finally, it is important to note that in addition to just broadcasting to space, because we're not really good at constraining the signal to our own planet, we've actually sent a specific message in 1974. If you've never seen it, this is how it looks like. Apparently, an alien would be able to understand what this means, even though most humans probably wouldn't. I guess the only thing you could recognize is probably this. This probably looks like a human itself. This message is made of 210 bytes. It was sent by the Arecibo telescope, which unfortunately has been destroyed. And it was essentially pointed at a globular cluster, even though it will be traveling through interstellar space forever and ever. And the Arecibo telescope has also been involved in trying to listen for any of these messages from aliens. And perhaps the most famous sort of tentative discovery was made in 1977, the WOW signal that you can see here, and also in the lecture notes, that was then shown not to be coming away from the Earth, and it was never repeated. The final thing to point out, again, talking about human broadcasts and putting that into context of whether we would ever be able to detect broadcasts from an alien civilization, this really gives context, the fact that we are here, this is our position within our galaxy, but ever since we made the first broadcast emission, this kind of sphere of broadcast is incredibly tiny. And this means that only alien civilizations within this tiny sphere would actually realize that we exist. If this is the case for all civilizations, and if they only last for a very short amount of time, the galaxy could even be populated with these, but these spheres very likely will never overlap, and therefore it is possible that alien civilizations will simply never talk with each other. And perhaps the best we can try to do is to look out for alien civilizations that have been long gone. This is it for section 11. I'll leave you with a summary of the things that you should now know. As always, I will encourage you to attempt the questions at the end. In this section, currently there's only one, but you will have another chance to actually apply what you learn in the worksheet, where you'll be able to perhaps discover and measure the properties of an extrasolar planet with real data. Once you're done with that, then I think we're definitely ready to move up in scale, not only look at stars and planets, but actually start talking about our own galaxy, how we determine our position within the galaxy, what is in the core, the center of the galaxy, and actually starting to look away even from our own galaxy to other galaxies and discover the diversity and the sheer number of galaxies that exist in the universe as a whole. So I'll see you for section 12.